Good evening. Today we have this as part 8, that is for your Insem and NPTEL. So this now 8th if I will talk, that will be for NPTEL. Now we are here for stiffness method. As we have seen slope deflection, actually Castigliano's we have seen, then we are with slope deflection, moment distribution, then Clapeyron's, that is theorem of three moments, and now next we have stiffness method. What are these steps? So in this actually we have to consider displacements as unknown, and in this method displacements are considered as unknown and forces as known. In flexibility, if you will see, we have formula that is dr, that is equal to drl plus f into r. Here we have considered displacements as known and forces as unknown. So this flexibility method is also known as force method, and as here we have displacement as unknown, so this stiffness method also known as displacement method. This is also known as displacement method. We have to go following steps. First, so structure is made kinematically determinate by restraining the displacements. We have to find out non-zero displacements, and whatever non-zero displacement we have, that is our size of matrix. Size of matrix, that is equal to number of non-zero displacement, and whatever forces we require, whatever forces we will get by making this kinematically determinate. Kinematically determinate means we have to make all displacement zero. All displacements as zero. And then whatever forces we will get, that is known as FDL, that is force at unknown displacement, which is D due to external loads. Force at unknown displacement due to external loads. Then we are going to be unit displacement is applied at the non-zero displacement, same as we are in slope deflection method. We are going to apply theta equal to 1, then forces we will get, that is 4EI upon L, and likewise we are going to be with this. And this, whatever these forces we will get, these are known as stiffness. And if we multiply this stiffness with the displacement, that is known as force at unknown displacement due to unit displacement applied at non-zero displacements, and that we will get as stiffness matrix. Then we have the external forces are known at unknown displacement, and this is denoted by FD. As we have dr, that is a drl plus f into r, and in most of the cases we have dr0. So similarly here in most of the cases we have FD is 0. Then we have to formulate the equations as we have formulated in case of flexibility method, and then from this equation we are going to calculate FD is equal to FDL plus S into D. Now we will see how we will prepare the stiffness matrix. So now we will go with displacement. We will assume all three displacement. We will consider here axial also and flexural member also. So we have first axial, I will say this will be 1. Then we have slope, we will say 2. And then vertical displacement, we will say 3. Similarly here axial we have 4. Then here we have slope, we have 5. And here vertical we are going to be 6. So we have 6 unknowns. So my matrix should be 6 by 6. And now we will apply unit displacement 1 by 1. So now first we will apply at 1. So what we will get? So we have beam is like this. So let us, I will say AB. Now we have to apply unit displacement. So by applying unit displacement, what we will get? So my beam will be shifted little bit ahead, and it will be like this. Now it is shifted to A dash B dash. And we have this value, that is delta is equal to 1. Now we have to find out what will be the forces developed. Now forces developed, if you will calculate now 1 by 1. So we have first, that is axial force, which I will say as 1. Then we have moment, which is for this second. So that is S2. Then we have reaction for vertical. We have S3. Then some axial force we will develop over, which I will say as 4. Then some moment here as 5, which is for theta B. And then we have vertical, which will be as 6. Now we have applied delta is equal to 1. So that is axial. So what is formula? We have delta axial, we have formula PL upon AE. Now we have delta 1. And if I will put delta 1, then I will get P is equal to AE by L. So what force we will require? AE by L. Now where we have applied displacement 1, so displacement is equal to 1. Displacement equal to 1 at 1. And this we have to write everywhere. So we have S1, then we have 2, 1, 3, 1, 4, 1, 5, 1, 6, 1. What does it mean? So force at first unknown displacement due to unit displacement applied at 1, which will be S11. S21 force at second unknown displacement due to unit displacement at 1. Same way S31 at 3 due to 1, at 4 due to 1, likewise. Now what is value of S11? We have AE by L. What will be S21? So it is 0 because no moment will be developed. We have axial force. No vertical force will be developed because we have axial force. But S41 we have summation Fx equal to 0, and we will get this value in opposite direction AE by L. Now S51 no moment will be developed, no force will be developed. And we have only two values, S11 and S41. Now we will go with second. Now what is second? So now we are second, that is unit displacement at 2. What is 2? 2 we have theta. First we have delta H. Second delta H A I will say. Second we have theta A. Third we have delta VA. Fourth we have delta HB. Fifth we have theta B. And sixth we have delta, sorry, this is delta VA, vertical direction, displacement in vertical direction at A. Now we have applied this as delta HA equal to 1. Now second we have theta A is equal to 1. And we know for unit displacement we have to apply 4 EI upon L, and that should be clockwise. So that is most important. We have to apply clockwise moment. So I will apply clockwise moment. So what is value of this? So moment required here we have 4 EI upon L. So now I will change the color actually, and then we have this will be 4 EI upon L. So I will just mark 4 EI upon L. So now try to understand this. So we have this will be 4 EI upon L. So what will be here? So we know half of this 2 EI upon L. And now I will mark. So we will have first S1, S1, then moment already we have here. So this is S2, vertical we have S3, then horizontal here we have S4, vertical over, sorry, moment over here S5, and vertical over here S6. Now where we have applied unit displacement at 2. So S1, 2, S2, 2, S3, 2, S4, 2, S5, 2, and S6, 2. As we have flexural, so we do not have any action. So I have S1, 2, 0, then I have S4, 2, 0, because no axial. Now S2, 2. So we have S2, 2 that is equal to 4 EI by L. Now what will be reaction? Now you can see if I will take moment about A0. Sorry, we have to find out S32. So if I will take moment about B0, then what I will get? So I will get 4 EI plus 2 EI, 6 EI by L clockwise. So what reaction will be developed? So reaction will be developed. You can calculate 6 EI upon L square. So I will write here moment about B0 and I will consider downward only. So minus VA into L plus it is moment need not required to multiply by L. So plus 2 EI upon L and that is equal to 0 gives me VA as 6 EI upon L square. Now apply summation Fy0. So I will get S62 that is upward 6 EI upon L square. And this S we have clockwise. So this we have S5. So S5 2 we will get it as 2 EI upon L. Because this we have moment we have fifth and this is S52. So S120, S224 EI upon L, S32 minus 6 EI upon L square, S420, S52 2 EI upon L, S62 6 EI upon L square. Now we will apply for sixth. So now we have sixth. So we will consider unit vertical displacement now. Now unit vertical displacement, so we have delta equal to 1. Again we will consider positive, and as it is clockwise we have considered positive. Same way we have vertical positive, delta is equal to 1, and we know for delta equal to 1 how much moment we have to apply, so that also we know. So we have moment required to take it up is 6 EI upon L square. And now we will go to the another color over here, and we have that is 6 EI upon L square. So just we will go 6 EI upon L square, and that is now anti-clockwise. So we are not interested with clockwise anti-clockwise moment. We are interested with unit positive displacement 6 EI upon L square, and we know here also we have 6 EI upon L square. Now we will write it. So we have here where we have applied at 3. So we have here delta VA equal to 1. That is third displacement. Here it was second. So in each term, second value we have 2. Now here each term we have second value 3. So I have S at 1, 3. Then we have moment S at 2, 3 due to 3. Then we have to find reaction. Now this is anti-clockwise. So we should have this value we will get now 12 EI upon LQ. This value will be S at 3 due to 3, S at 2 due to 3, S at 3 due to 3. Then we have axial S at 4 due to 3. This is also 0. Then we have S at 5 due to 3. So S at 5 due to 3 is again minus 6 EI upon L square. And by summation Fy0, so we have S at 6 due to 3, which will be equal to 12 EI upon L cube, but that is in downward direction. So same way you can go for other three, that is 4, 5, 6, and we will get same values. And therefore, if we will prepare the matrix of this, then we have, so let us, I will go, so this is first, then second, third, fourth, fifth, and then we have sixth. And then we will go one by one. So we have this will be first. And we have first, we have written black color. So I will go with black color only. So you will understand it easily. So we have S11. So S11 we have AE by L. S at 2 due to 1. So now we have symmetric matrix. So S12 equal to S2, and that we have. So second row first column. So I will write here second row first column. So what will be value? 0. Then we have S31. So S at 3 due to 1. Then again we have 0. Then we have S at 4 due to 1. Then we have, if we will see at 4 due to 1, we have minus AE by L. Then you can have at 5. So we have at 5 again 0. And 6 also we have 0. So we are being in this fashion. Now we will go for second. Now second we will write by blue. So you will understand it. So we have by blue. And then first value S12 we have 0. S22 we have 4 EI upon L. Then we have S32. So we have minus 6 EI upon L square. Then we have S42. So we have 0. We have S52. We have 2 EI by L. And we have S62. We have plus 6 EI upon L square. Then we have third, and we will with the same color third, and then we have this as S13, then we have S130 again. Then we have S23, we have minus 6 EI upon L square. Then we have S33, we have 12 EI upon L cube. Then we have S43, again we have 0. Then S53, we have minus 6 EI upon L square. And S63, we have minus 12 EI upon L cube. And this matrix is symmetric. So we have this will be 1, 2, 3, 4, 5, 6. So we have then 1, 2, 3, 4, 5, 6. Now we have this value as 41 and S14. So this value S14 should be equal to 41. S41 we have minus EI upon L. Fourth row first column. And this is first row fourth column. And we have this value minus AE by L. Now this is as second row fourth column, then fourth row second column 0. So we have 0. Symmetry we have to maintain. As we have third row, so this is third row, and we have column 4. Reverse S43. So we have S43. S34 and S43. S43 we have 0. So we have this value that is equal to 0. Then we have S44. So we have S44. So what value we will get? Both we have 44. So we will get this value AE by L. Now how we will get 44 AE by L? So just you understand, we have this will be 4. We have to apply unit displacement over here, and this will be AE by L, and this goes the reverse, which will be AE by L. Equal and opposite, and therefore we have S at 1 due to 4 minus S at 1 due to 4 minus AE by L. S at 4 due to 4 we have plus AE by L, and then we have this will be S51 and S150, and then S64 and S64 and 46 we have 0. And similarly we can go over here S15 and S51. So we have value 0. So we have this value 0. Then S at 25, and then we have 52 2 EI by L. Symmetric matrix we are preparing. Then we have S35, and then we have S53, minus 6 EI upon L square. Then we have S 4 5 and then S 5 4 we have 0. Then S 5 5. So S 5 5 means we have to apply unit displacement here and we will get it as 4 EI upon L. So we have this value 4 EI upon L clockwise. So we have this will be 4 EI upon L. And then we have 5 6. So and then we have 6 5. So that is at 6. So you can have this clockwise. We can have this clockwise. So automatically this should be positive upward 12 EI upon LQ. Then we have x61. This is 0. Then we have x26 and we have 62 6 EI upon L square. Then S36 63 we have 0. S46 and we have S64 we have 12 EI upon LQ. And then we have S65 56 and then 65. So this is 63 and then we have 63 minus 12 EI upon LQ and then 36. So sorry, here we have correction. So we have 63 and 36. So here we made a mistake. So you can see this. What is 63 value? So we have 63 minus 12 EI upon LQ. So 636. We have minus 12 EI upon LQ. Now we have 46 and 64. We have 0. Then we have 56 and 65. We have 12 EI upon LQ. And then we have 6. We have to apply at 6th unit displacement. And for this unit displacement, we have to apply moment that is clockwise. And therefore it comes 6 EI upon L square. And so likewise, we have this matrix 6 by 6, which is known as stiffness matrix. So we will stop here only. So tomorrow we have assignment of this. And in that assignment, you will come to know how to solve these problems. So thank you.